When we teach MBD, we break it into 4 parts: geometry, annotations, attributes, and presentation states. The first part of MBD is the geometry, and it is just what the word implies. It is the shape of a part or component. When it comes to MBD, we know it is capturing the 3-dimensional mathematical functions and coordinates that represent the shape you want to build. Because the shape is digitally captured, for the cases where the 3D CAD is used directly to feed a CAM machine, we don't need to show the dimensions through an annotation or on a drawing. And if you're familiar with geometric tolerancing, then the 3D model becomes the basic dimensions. Once the shape is set, the next step and second part of MBD is to apply product and manufacturing information, or PMI. At Action Engineering, we like the American Society of Mechanical Engineering ASME definition of annotations and attributes that capture the PMI. These are the 3D tolerances, notes, and symbols that are digitally attached to the features in the geometry that they represent. The Digital Product Definition Data Practice Standards, ASME Y1441, asks CAD vendors to not only ensure that manufacturing software programs know the relationship of the annotation to the geometry, but also to provide humans the ability to see the digital relationships on the screen. If we see it, we have increased confidence that the annotations were properly authored. Per ASME Y1441, attributes are the information that are not visible on the model, but are available upon interrogation of the model. I like to think of this information as metadata, and in many CAD systems, attributes are called properties or parameters. The most common attributes are part number, part description, and material. In 2019, ASME Y1447 was released that recommends the type and nomenclature of metadata in the effort to standardize attribute interoperability across native and neutral CAD systems. As we transition from a presentation-based mindset, meaning presenting data for humans to read, into a computable data authoring mindset, often referred to as model-based definition, it becomes a courtesy to the human reader to prepare presentation states to easily read information. As in a drawing, this information is not machine readable, but it helps us to build trust in the annotations that are machine readable, meaning it takes a human carbon-based brain to interpret the data being displayed in a presentation state. If you're familiar with old-fashioned software coding, you may think of a presentation state as a print-to-screen routine call. There will be a time in the future when we don't need presentation states because the data moves seamlessly from one 3D format to another. But today, we find that a few standardized presentation states really helps MBD adoption. And those are the 4 parts of MBD. Geometry, annotations, and attributes are intended for machine readability or computer software consumability, and presentation states are really only for the humans.